Okay, in problem number 6, we have a force of 215 newtons applied horizontally to our 18.3 kilogram box to move across a level floor. Coefficient of friction is given as 0.35. We are trying to actually find the acceleration of the box. That's a little bit unusual. So in this particular problem, we'll start off with our box sitting on a level floor, and we are going to apply 215 newtons of force on this thing. Friction is going to come along and apply some kind of force in the opposite direction, because like we talked about, it's always a force that opposes the motion. We have gravity acting downward on this thing. That would be the weight of this object, mass times gravity. Since we have the mass, we could find that. And last but not least, we have some kind of normal force acting up on this thing. So if I'm going to find the acceleration of this box, really what I'm going to be using is Newton's second law, F equals m times a. But this is the net force acting on it. In this case, it's going to be made up of two forces. It's made up of my 215 newtons minus the friction force. And the reason why I'm subtracting the friction force is it's opposing the motion of this object. That should equal m times a. So I have the mass of this object. I can put the mass in there. I could solve for the acceleration of this object, but what I need is the friction force. That's when our equation for friction comes in, the fun equation. We're given the coefficient of friction, so I have that value, but what am I going to put in for the normal force? Well, the normal force is equal to the weight in this case because it's on a level floor. So the fact that we're on a level floor, the normal force just equals the weight, or in other words, it has the same magnitude as my weight, and it's also equal to m times g. So I'm going to substitute that into this equation, and fun becomes mu times, and for the normal force, let's put in that it's equal to the weight, but I'm going to put in that it's equal to m times g. I have sometimes left this equation like this, but I like to rearrange it and be silly. I will sometimes put the m in front and refer to this as the mug equation. Or I had a student one year say it might be better, Mr. Hennon, if you put the g in front and refer to this as the gum equation, because friction would come if you had gum on your shoe. So now we can use our equation. We have 215 newtons minus the friction, which is going to be the gum equation. We have all those pieces. Gravity is 9.8, coefficient of friction, the mass. Over here we have mass times acceleration. We know the mass. We should be able to find it. So from this, we should be able to find everything, and it really all stems from Newton's second law.